This is Patrick Dolans with the first of two presentations that will focus on what's known as the circular flow model. The circular flow model is our first macroeconomic model. In this model, we're going to assume there are two groups that we need to focus attention on. One group consists of households, the other group, business firms. The groups are not mutually exclusive. So, for instance, Bill Gates is part of a household, and as part of a household, he consumes the kinds of things that you and I consume: groceries, entertainment, blue jeans, etc. Bill Gates is also associated with Microsoft, which is a business firm. We're going to assume that these two groups interact in two different markets. The first market is known as the factor market. In the factor market, businesses spend money to purchase factors of production from households. The money that businesses spend is known as income, and it takes various forms. So some households will receive wages or salaries for labor as a factor of production. Some households will receive rent in exchange for access to land or buildings. Some households will receive profits or dividends. In exchange for these sources of income, businesses receive access to land, labor, capital, entrepreneurship. Those are known as the factors of production. We assume an exchange of equivalence in this market, and so that simply means that if $1 million flows from right to left in the diagram in the value of monetary income, then $1 million worth of factors of production flows from left to right. That doesn't rule out the possibility that there could be some individually bad trades, but in terms of the overall total, we don't assume that households systematically cheat businesses or vice versa. The second set of interactions is known as the product market. In the product market, businesses take the goods and services that they produced using the factors of production that they purchased and sell those goods and services to households. Households take the income that they've received and engage in consumer spending, or in this model, consumption. Once again, we assume the exchange of equivalence. That simply means that if $1 million worth of consumer spending is flowing from left to right, then $1 million worth of goods and services are flowing from right to left. When we put the two markets together, we end up with the basic circular flow model. As you can see in this model, monetary amounts flow counterclockwise through the outer circle, while stuff moves in a clockwise direction in the inner circle. The basic circular flow model gives us a framework for understanding how a fixed quantity of money can cycle through the economy endlessly and how an economy can reproduce itself. Businesses provide households with the money they need to spend. Households provide revenue to businesses so that they can produce more goods and services in the future. If the basic circular flow model was the complete story, it would hardly be worth the time that we've already put into it. However, we're going to introduce a key identity, and with the introduction of this key identity, the model suddenly takes on a new importance. The key identity is the idea that the total value of income generated during the production process is exactly equal numerically to the value of the output produced. This claim that total income is numerically identical to total output is signified using the symbol of 3 lines rather than an equal sign. If you're familiar with mathematical identities, you've seen this sign before. If you're not, what you need to understand is that total income equal to total output is always true. Wait a minute. Always true? Yes, always true. There are no exceptions. Indeed, relatively soon we'll discover that economists use the same name for national income as they do for national output. That term is called gross domestic product, by the way. Okay, so what? Well, this brings us to the implications of the key identity. So let's put the pieces together. First of all, if total income is exactly equal to total output, and I've just told you that that's always true, and if all the products produced are in fact successfully sold, which is not always true, but certainly desirable, then what must be the case? That's the mystery that goes in the blank line. But hang on a moment. Let's think about that second line. If all products made are sold. I suggested that that's a desirable, though not necessary, outcome. Think for a moment and see if you can figure out why that's a desirable goal. From a macroeconomic perspective, because this model really is about the bigger picture. From a macroeconomic perspective, if businesses are able to successfully sell the products that they produce, which is what that second line suggests, then businesses will be inclined to continue doing what they've done in the past. If businesses continue to do what they've done in the past, then people who had jobs yesterday are likely to have jobs tomorrow, and things should continue to function in a relatively smooth and stable fashion. But if firms cannot sell the products that they're generating, then we have a potential problem. If firms start to stockpile unsold inventories, one possible response is to cut back production. And cutting back production means cutting output, which means cutting income. More specifically, somebody's likely to lose their job. And as people lose their job, they engage in less spending, which means firms will have more difficulty selling products in the future. Hopefully you can start to see that if all products made are not sold consistently and economy-wide, then we could have a mess on our hands relatively quickly. But let's return to solving this puzzle. If total income is exactly equal to total output, and if all products made are in fact successfully sold, then what must be true? Well, another way to look at this is to think about what we've identified. We have total income and total output in the first line. But look carefully at the second line. The second line also contains total output. It just calls total output all products. So if total income equals total output, and it always does, and if total output matches total sales, which is what the second line says, then in fact, one thing must be true. Can you figure out what it is now? Here's the answer. If total income is exactly equal to total output, and if all products made are in fact successfully sold, then it must be the case in this basic circular flow model that total income must match total sales. Another way to say that last line is that all income must be spent. If you pause for a moment, you'll almost certainly recognize that all income does not get spent, in which case we have a problem. But that's the topic for the next presentation.